All right. Let's take a look at this. So we already talked a little bit about 1B, like I said. We'll break out here at about 1:45, and then we'll spend the last 15, 20 minutes going over the exam. We're going to talk about structured task scope. Can you guys, can you remind everyone else, I want anyone to speak up. What is structured task scope? What does it allow us to do? This will be on the test, by the way, structured task scope. Anyone remember what it allows us to do?
It allows us to run our code concurrently.
Yeah, that's exactly right, Hamza. It allows us to run our code concurrency. Is it the only way that we can run our code concurrently?
As far as I know, yeah.
As far as you know, it actually isn't. We can run it unstructured too. We can just fork things off and create threads and just create virtual threads or platform threads, and we can go to town. We can do all those things. What structured task scope does is it gives a structure around it. And if you remember, what does that mean that it gives us structured? What are the benefits of structured concurrency?
Well, it gives us some nice ways to wait for all of the tasks to be done.
Yeah, Aaron, yeah.
In different ways, I guess.
Yeah, in different ways. It helps us prevent zombie tasks, orphan tasks. It gives us a way of coordinating tasks to do things. It gives us hierarchy of tasks. I can have subtasks inside of subtasks inside of subtasks. If I'm using just fork or thread, there's no kind of just automated management of those threads. There is in garbage collect, but there isn't structure to them. They're all unstructured, which means I can do crazy things. I can run things in massively parallel or semi-massively parallel. I can write my own orchestrator and scheduler. This gives me some structure to it, so I don't have a whole bunch of code out there handling threads. I can focus on the functionality I need to. So that's, you think of structured task scope as giving us some structure to that chaos that normally you see with concurrency, which means running all of our stuff in parallel, right? Last week, we talked about shutdown on failure and shutdown on success. We're going to go even more in depth on those today. So, and I want to make sure that you guys understand the concepts behind it, because the concepts are more important than the actual code that we see, right? In fact, maybe we'll have some fun one of these lectures, and I'll show you how we would do the similar things in another language. So you can see, it's almost like when you learn another language in speaking, you start understanding the language that you natively were born with. You start understanding different constructs. So maybe next week, if we have some time, I'll show you some ideas on how you would do this in another language. So the concepts kind of stand out a little bit more. Because these concepts here on concurrency and structured concurrency is not unique to Java. In fact, many of the modern languages have it already built in, like Node.js, Rust, Go, Python has the same kinds of concepts that are now in there, okay? So, and then at the end, we're going to talk about the exam. So let's dive right into shutdown on failure. So shutdown on failure, what, just by the name alone, what does that tell you?
It shuts down whenever you encounter a failure.
But yeah, that's exactly right. It shuts down when any of the subtasks that are running fails, any one of them. Okay. Now there's another thing that happens. It also means that it's going to run all of the tasks. If they're running good, it'll run all of the tasks, and then when all of them are finished, then it will return. Okay. So as you remember, with the try scope that we have here, that scope where I'm running the forks off of, that scope will say I'm done when all of the tasks I've completed or when one of them fails. And if one of them fails, what am I guaranteed about the other threads that are running, the other subtasks that are running? Anyone?
Those will stop as well.
Yes, they will stop as well. And this is important to that concept that it's going to manage things for us. Okay? It's going to manage the cleaning up of threads and the subtasks for us. We don't have to do that, which is nice. Because doing that on your own can be a real pain. Okay? So think about, it's essentially saying invoke all, run them all in parallel, wait for them all to finish, and then return unless one unless one fails. Okay. All right. If I look at shutdown on success, what would you say that would be? This one's a little bit counterintuitive. This one gets, people feel a little uncomfortable with this one.
First success, it shuts everything down.
On the first subtask success, it shuts everything else down. Yep. Exactly. That's exactly right. So it's like invoke any. Invoke all of these, and whoever's first, I'm done. Shut everything else down. The scope ends when all of the subtasks are complete, are down. I'm guaranteed that they're all down. Okay. All right. Let's take a look at some code now. You guys should be familiar with this. This sort of concept will be on the test. Okay. It's used with the try with resource failure pattern. So I'm going to try with this scope. I created a structured task scope, which is shut down on failure. All right. If it's shut down on failure, what's going to happen? Anyone? There. Come on, guys. Don't be shy.
If it shuts down on failure, then all the tasks will end and it will fail. It will throw if failed.
If one of them fails, it will throw a fail, right? Okay, good. They will all run to completion unless someone fails. Remember that. That's important. Okay. We use the concept of future. Now, in more modern Java, like Java 21 and above, they use another word instead of future called supplier. If you see that, just think that's future. It's basically the same concept. In other languages, we see this concept is called promise. I promise I'll give you a result later. Future, in the future, you'll get this result. So in this case here, I'm saying scope, fork. Fork means I'm going to start a thread and I'm going to go find that user, and the results are going to end up in user. And this user is really a promise that I'm going to get a result sooner or later. I don't know when. Right? It's just kind of a holder there sitting there. All right, when I do get that result, then I'm kind of notified. Okay. So as you can see here, how many subtasks do I have running in this try block? In this task, how many subtasks do I have?
2.
2. Really easy. How do you know, Hamza?
Because of the scope fork, there are 2 instances of
Scope fork. That's right. Now, you could make a huge mistake here and just do fork without scope. What would happen? What if I just use fork without scope?
And then you lose that structured scope. You are now in an unstructured kind of fork where you're not guaranteed the kind of auditing that scope gives you.
That is correct. You just created another thread that is not in that scope. So the scope may end, but that other thread will continue on. And it may be chewing up resources. It may cause you havoc. You don't know. Okay. So just remember, if you don't put the scope in there, right, and the scope is defined up above, right, in the try block, then you could run into an issue, right? So you'll get a leaked thread, a leaked subtask. Okay. That has happened. Okay, the join here this is the barrier or the synchronizer that says, hey, this is where everything comes together before I go and grab results or whatever. So remember, for this one, this join, it's for on failure, which again means if one fails or all of them complete. This will join, bring it all back together. If an exception occurs, then I can use throw if failed. What this will do will throw an exception. So if I don't put this in here, what will happen? If there's an exception in one of those subtasks, what will happen? Anyone? If I don't put throw if failed. No one knows? Aaron, you went off mute, so I'm assuming you
Yeah,
know.
well, so I'm not 100% sure, but I'm pretty sure that all those future things are going to end up being null.
Those future things, one of them could be null, one of them could be valid. I don't know which
Yeah,
one.
that's fair. It's going to be like you don't know what you're going to get back from that future stuff, and so you can't trust it, I believe.
That's a very good, Aaron. You nailed it. You can't trust it. So if you are looking for failures, like we are here, shut down on failure, then and you're not testing the individual values from those futures, then use the throw if failed, because this will make sure that you're throwing the exception beyond the subs tasks into whoever called the task in the first place, right? And you're not going to return, bogus data. Right? So this is a best practice. There are some cases where maybe you want to do something a little more funky, and you can do that as well. Okay.
So in Gradle though, with that, like, wouldn't it keep running until like all the trying to complete the build process, and then at the very end, once it all goes through, then it'll finally say it failed?
No, if
Or-
one of them failed, as soon as one of them failed, it closes all of them.
Okay.
Right? So the other ones will come up as undefined or null, right? And the one that did succeed, or the ones that did succeed, you'll be able to get the future values out of. Good question, Elle.
Thank you.
Okay, the last one here. This is, remember, return results. This is non-blocking. So if someone's out there sitting and running the task, I'm not going to block the thread, right? Because and if you notice here, I'm not returning the future, I'm returning the value inside the future by using get. Okay, that's a common mistake I've made. Well, hey, I declared it as user, right? I'm just going to return the user that I got. If you're using future, then make sure that you use get to get the value back out. This will make sure that it doesn't return until those values come in. Or I should say till the scope is over. Right. Okay. Any questions? You guys should be able to code this up, no problem. No issue. If I wanted to do 10 subtasks, what would that look like? I would have 10 scope.forks called in there, right? If I don't care about the values it's generating, I don't know why you would do that. Maybe you do that because it's updating a database or something. Don't know. Then I don't really need to grab a future. I could just say scope fork and just let it go. Okay. All right. Shut down on success. What's the difference? Again, I'm going to repeat this like 5 times so that you guys remember it, because it will be on the test. Shut down on success. What's the difference?
The first successful thread that comes back will return, and then all the other threads will get shut down.
Yep, that's exactly right. If you have a favorite a favorite job that takes longer than the other jobs, do not use this, right? Because it's kind of just whatever one comes back first, it's going to use, right? So, pay attention to that.
So
Yeah.
is that the like if the build succeeds, the Gradle shuts down on the first like daemon. And then if a build fails, the daemon it remains running for debugging. Is that right?
If you're thinking of it that way, you can kind of think of it that way. Yeah, you can kind of think of it that way if you're using this concept. Yep. Shut down on success. One of them succeeds. Of the subtasks, I'm done. Everything else gets shut down. It may not even, if you're using it, I wouldn't use this for a build. If you're running parallel tasks, because I compiled one library. I don't care about the others. They'll never get compiled all the way. When would you use something like this? We talked about it last week. When would you use this? Sounds like a weird use case. Shut down on success, the first subtasks, and I just, I kill the other subtasks. Why would I do something like that?
Maybe you have a series of computations you need to return, and then based on the methodology you use, whichever one returns first is the first one you'll use.
Yeah, perfect. Like a sort algorithm. I'm going to
Yeah.
run this against 5 different sort algorithms. If you want to waste resources, you would do something like that. Anything else that that might work for this one?
I had an idea, but I completely forgot about it. Sorry.
It'll come back to you. Gaming. This would be a huge one in gaming. Think about gaming, all the gaming scenarios that you could use this for.
Yeah, so like memory because like it would shut down like if you had limited RAM or something, or like if it's like a shared system, your like CI or CD runner, you for memory. I don't know.
Well, that could be an interesting one.
Okay. So pinging an API. Let's say that you've got multiple different APIs. You got to ping. Let's say you're trying to. Okay, I'm trying to hit a server that's close by. Whichever happens to be the one that returns successfully, that this user is authenticated or something like that. Boom! I found out
that's the one I'm going to use.
Boom.
Yeah.
Oh.
Think about having a Gen AI in the back end. Let's say I've got 10 different Gen AI models running, and I'm going to ask all 10 the same question, and I only care about which one comes back first. Boom. Done. I kill the others, saving myself some bandwidth maybe when they come back. So it's like first winner. Okay. Let's take a look what the code looks like on this one. Now, this one's a little bit different, right? Because the results that I get out of the scope is going to be the result of the first one that comes back. Think about it. So in this case here, you can see that I'm passing in, I'm using a try with scope, but you can see that on the shutdown here, oops, I clicked too soon. On the shutdown here, I've got shutdown on success, and I'm expecting it to have a list of big fractions coming back out. Because I'm only going to get one result back out, and it's going to be a list of big fractions. Where in the other one, I could get multiple results coming back out. And so that's why I grabbed the futures from the individual forks. With this, the results are coming back into the result itself of the scope. You see the difference? And I'm specifying what that is right there. Okay, let's take a look. That was a duplicate. Okay. So on this one, again, how many subtasks am I running? Easy answer. There's 2, right? And remember, whatever one comes back first wins, and that's what's in the scope results here. Again, in parallel, whichever one wins, I get the one result back. The other result is ignored, dropped off. See you later, alligator. That heap sort, if it's taking longer, is killed. Okay. All right. I already mentioned that they're running in parallel. I still need the scope join. That's going to wait for the results. Whichever one wins, that's where I'm saying, hey, this is where I'm getting back. I need to specify that. And then, of course, I'm returning the result. The result here, will it be a future or not? The result will not be a future. It will be a list of big fractions, as I specified in that template definition up here. Right there. Okay. Okay, any questions on this? This is a lot easier. You can see this is a lot easier to program because I don't have those futures that I'm working with. I'm only dealing with the result of one of them, which is nice. Okay. All right, any questions on this task scope? No question. So you guys could all code this up. No problem.
I do have one question. So the scope that result returns the result, and because they're the same, we're expecting the same type to basically go into the fork. We can use scope that result, but the scope still have a get method associated to it, or no?
In this case, the get method is already, so what happens under the covers is inside this code, inside the shutdown on success, it's handling the future get stuff all for you. So when it actually comes back on that result is sitting on a future that is waiting for that get to resolve, right? So that's handled for you. It just makes the code look cleaner. So I don't have to do a get on this because that's happening under the covers.
Okay, that makes sense.
Yep.
Thank you.
Good question. Any other questions? You guys get it? All right. Let's talk about custom structured scopes. Aaron, this one's for you, buddy.
Thanks.
Aaron asked last week, hey, what if I have 100 subtasks, but what if I only want to return a result when I get 25 of them back, and they're within some statistical, variance? That is a very valid case. We see that a lot in scientific computing, where they're running these massively parallel jobs. You can see it a lot in like genetic algorithms. This would be great for genetic algorithm. Or maybe you have a custom structured scope that's looking at the data itself and saying, hey, I'm going to ask the same question 5 times, and then I'm going to ask another question 5 times, and then and they're all subtasks, and you're saying, I need a collection of different results coming out of all my subtasks. And once I get those, then I can shut everything down. Okay. Anything you can dream up, Aaron, we can do. All right, you want to learn how to do this?
Definitely.
All right. It's actually easier. It's actually pretty slick. It uses the concept of inheritance, right? So we're going to extend the structured task scope. And basically, when we look at on complete, on failure, and at the other two task scopes, they do the same thing. They just inherit from structured task scope. And then we need to implement desired behavior on handle, complete, and get results methods. So we're going to walk through an example. Okay. This is actually a pretty cool example because at first I wrote it as shut down on 2 successes, and there's some, but I changed it later to shut down on n successes instead of 2. So we could pass in a parameter. So if we rename this to shut down on n successes, meaning more than 1, any number you want, and this is me extending that structured task scope there, right? I'm going to add these 3 private variables or attributes. I'm going to add an atomic integer. Now, the reason I add it as atomic is because I want to make sure if I have 100 subtasks that they know that only one of them can update it at a time. That's what atomic integers are, right? I'm going to have the
Question on that.
Oh
So
yeah,
are integers in Java not thread safe, or are you worried about like phantom updates?
I'm worried about phantom updates.
Okay.
Yep. Okay. I also have another number, and it's the required number of successes, which I'm going to pass in, which you guys will see. I'm going to pass in when I start the scope. I'm going to basically say I want 2. When I get 2 results that are successful, then I'm done, or 3 or 4, whatever number. And then I'm going to store the results. I'm going to store the results in a linked queue. Again, I'm using concurrent linked queue because I want to make it thread safe, make sure that I don't get, stepping on top of each other. And so I'm going to store the results of each subtask into results. Okay. It's pretty simple so far, right? Very straightforward. All right. Now I'm going to rewrite. This is the constructor. So this is the public method of the constructor, which is shut down on 2 successes. Like I said, I renamed it. I forgot to rename it everywhere. This should see shut down on in successes. So let me change that code right there. Horrible. You know what? PowerPoint does not have a code checker built in. It really should. Let's change this one here too, so you guys don't see that as an error later. All right, here we go. So all I'm going to do in the constructor here is I'm going to pass in the number of required successes, and I'm going to store that into that private variable that I set up here. Required successes right there. All right, so I'm going to use that. I'm going to use that number. I'm going to use that attribute. Okay, you with me so far? Any questions? No questions. All right, let's do the next one. Now comes the magic sauce. The magic sauce is I'm going to handle every complete subtask. So when a subtask completes, I'm going to check its state. If its state is successful, I'm going to add it to the results. And you remember, Hamza, do you remember when I said, hey, we hid the futures under the cover because we did the get under the cover? Right here. There it is right there. The subtask, I'm saying to the subtask, get your value, jam it into the results. Okay. And then here I'm going to check, is the success count was that atomic integer, increment and get. Is it equal to the required successes? If it is, then shut down the scope, which will shut down all the rest of the subtasks. I've stored the results of the number of subtasks that I was watching for, and I shut down the rest. This handle complete. This is where you would have all your complex algorithms, Aaron, that you want to look at threads and determine which ones you want to shut, how many values make it to success or not. Okay.
And then one other question I had along these same lines is, so like I've got I do like a try where I declare my scope. And then in theory, could I kick off like 3 threads, and then as soon as one of those threads completes, let's say I kick off another 3 threads using the result of the first thread while the other 2 threads are still going. Like, can I do like nesting or something like that?
You could do nesting, but I would do it by having a try scope inside a try scope.
Okay. Okay. So I can nest the scopes and
Yes.
then
As deep as you want.
Okay.
Yep. As deep as you want. That's how I would do it.
Okay. Or I could use this thing, and with that handle complete method, since you're overriding that and you can do whatever you want in there,
You absolutely
could notify somehow
You
I
could
mean, you could
even,
pass in an anonymous function even, right? Where,
yep, you could pass an anonymous function or a list of anonymous functions.
okay. Oh, whatever developers were working with me would
Would
cut
kill
me
you.
up.
Yes. They would hunt you down, Aaron, because it would be so hard to follow.
Yeah.
So a better technique might be to, if you're doing something that complex, to use a workflow engine and a generic tool that does all this for you. Use a workflow like JSON file or concepts of workflows, and then handle all. Then this, you could build it dynamically. You could say, hey, this subtask finished. What else was in the data structure of the subtask? Is there any subtasks to run now? And you could say, yeah, I could kick those off now. Create a new scope dynamically. That'd be easier to debug.
So could you, I don't know if this was handled, but could you theoretically have more required successes than actual threads running in this case?
No, you can't.
You can't? Okay.
Yeah, that's a great question, Hamza. I can't have more successes than threads running. So that's a very good question. And I would have to go look and see how I could get the list of subtasks in the scope. I'm sure there's a way I can. I just don't know off the top of my head. So when someone declares the scope and they fork off the threads, I could have in here saying, you never provided enough. There was never enough.
Yep.
Never enough to reach the criteria. You would probably have to put in some kind of a timer to do that. So, but yeah, otherwise, yeah, it would never end. That scope would never end.
Okay, so I mean, if it's still a structured scope, at some point it has to time out, right? Or just it doesn't.
It doesn't, not unless you told it to time out.
Okay. Well, that's an infinite. Not even a
Yeah,
loop.
there's a bad case right there, right? You could have a whole task and its subtask sitting there forever. Now the subtask will eventually, end, but the scope could sit there and never return.
So for this exact example that you gave here, is it really for like when you only care about the certain number of successful results instead of like waiting for all the tasks to complete? Is that the?
Yep, that's correct. Now, what if we want to change this up, Bill, and say, hey, I want to look at 2 in tasks on failure. I only want to quit the scope if 2 of the tasks fail. That would be kind of stupid, but we could do that, or we could set a threshold of failure, only end when it's totally complete or when 2 of the things fail. And if we were to put that code in there, that wouldn't be that hard to change this to do that. We would say subtask state dot fail, right? And count the number of failures. If it hits 2, then shut down. Or if all of them have succeeded, or if all of them are done, then shut down. I could do it either way, right? So that would be another case. And I see that case as a very good case. When I can say, I want to continue forward if I only have a certain percentage of the subtasks fail, I'm okay with that. It's still within the threshold that I'm okay with. Like 2 out of 10 or 2 out of 100 would be okay. But as soon as I go to 3 out of 100, something's really wrong, so I'm going to stop the subtask. That could be the case. Okay. All right. Let's see how we can use this class. Oh, wait, no, there's another method. Do I have another method? I do. No, I did handle on complete. Oh, the get results, right? So remember, I have to get the results now out of the scope. So I have a get results that I put in there. I put in here specifically if I didn't get enough tasks finished. So Hamza, it's going to throw an exception. If I do get enough, then I return the results. Right. You notice I put the join in there. The join says, don't run this code below there unless everything's done. Okay. All right. All right, this is how I would use it. So if you remember, I created a shutdown on in. Gotta change my code here a little bit. Shutdown on in successes. I'm going to pass in strings to it. That's what I said, you know, is going to be coming out. And I said I only wanted 2. You see that 2 right there? That says only 2 of these need to succeed. And then I'm done. Okay. So I fired off how many subtasks did I fire off here? They're really dumb subtasks. They sleep for a little bit and then return. How many subtasks do I have? Anyone? LaShawn, I haven't heard you today.
It sounds like 4.
Yeah, there's 4.
Yeah.
There's 4. How did you know, Jonathan?
There's 4 forks. And it also counts the 4. So task 1, task 2, task 3. Task
Yeah, I made it easy. Right. But it's the scope fork that is telling me, right, that, hey, this is a subtask. Okay. In this case, which one, what are my results going to be running this little piece of code? When I do a get results, what's it going to return? More than likely, not guaranteed, but more than likely, what's it going to return?
It'll return result 1 first and then result 2.
Yeah, probably result 1 and 2. It could do 1 and 3 if for some reason task 2 took a long time to get started. Right? It could. We're not guaranteed. Now, that's another thing I want to get across to you guys. Just because you put them in a certain order here does not guarantee the order that they're going to run. And one could take a little bit longer to get started than another. Typically, it's not going to be 100 milliseconds like I have on here, but you never know. So don't be guaranteed they have the order. I do have an exception in there, a runtime exception that task 3 failed. That's going to fail first. Is it going to stop? Nope, it's not going to stop because I didn't capture that exception. I could put a try catch block in the code above. Up here, I could put a try catch. No, not here. One more up. I could put a try catch block in here around the state. That wouldn't do anything. There's other methods that I can grab that exception. Okay. The complete might be one of them. I'll have to double check on that. But here are some methods that you can override in the structured task scope. You can even override the other scopes that have already been, I can inherit from them, or even override the methods that are in there. So in this case, if shutdown is called, I can override that. I can override shutdown itself, or one with the throwable cause in there, or handle complete. I'm guessing the shutdown with throwable cause, it's going to give me the exception on one that's shut down, or the exception that I'm passing on. Okay. Let's stop the share now. Any questions on these scope things? Aaron, you got it? That custom scope thing? Pretty straightforward. Yep. They made it easy. Okay.